The reason I joined this class was, well, space is pretty cool. I mean, Space Jam is my favorite part about it, but...
Alright, I'm Hunter Goebel. I joined this class because my sister inspired me to. I thought it would be a fun class.
We are missing our third group member, Eduardo. He couldn't make it tonight.
Alright, I'm starting off with Isaac Newton, the discoverer of gravity. Alright, so his birthday was January 4th of 1643. He was born in the United Kingdom, and this is the college he went to. As a kid, his parents were pretty overprotective, so he never really got the knowledge he needed until he got older and then went to Trinity College. Alright, his discoveries, of course, he discovered gravity by when he was sitting underneath a tree and an apple fell on him. He also invented calculus for mathematics, made it easier for it to do math. And he also made the reflecting telescope. Alright, gravity. His theory was that if you threw it higher and further enough, it would go further, and if you threw it hard enough, it could get into Earth's orbit. And since he thought of that, he thought that that's how the planets worked, is that they all were in gravitational pull to the point that that's how the system works. What is a reflecting telescope? It's basically this. It has a ton of mirrors in it to reflect light that he saw from out in the sky, so he could see all the stars. What happened to him afterwards is that he died in his sleep. Some people say that he died from mercury poisoning, but they're not really that sure.
So this was our other group member's project, or his astronomer, but I'm going to try to cover it for him. This is William Herschel. He was born in 1783 in Hanover, Germany. Died in 1822 in Slough, England. William grew up in a family of musicians. At age 19, he fled to England, where he made a living through music for a short time. Later, with his sister at his side, they both began getting interested in astronomy. Really, it is what started it all. At first, he bought his telescope, but after not being able to see more of what was out there, he started developing his very own. His discovery was that of Mars and Jupiter's axial rotations. He discovered Uranus. When he had ended up discovering Uranus, he actually wanted to name it Georgium Sidum, after King George III. And after he had discovered them, his sister and he became the king's astronomer and assistant to the king's astronomer. So his other discoveries, he discovered 2 moons on Uranus, which is Oberon and Titania, which are the 2 on the far left, and then 2 on Saturn, Mimas and Enceladus. And he also discovered infrared light in the 1800s, which is still used today. It is the light region beyond the visible light spectrum that we are not able to see without using technology. Some of the things used today are like scopes for military purposes or to help find lost people. That's all he has on him. This is my astronomer, Urbain Le Verrier, born on March 11th, 1811. He was born in Saint-Lô, France. Died in Paris on September 23rd, 1877. It's a picture of him and where he was born and where Paris is in correlation. When he was younger, he went to Polytechnic School, which after his discoveries he ended up teaching at and then getting fired and rehired to do the same job. He found the position of Neptune by using only mathematics, which the only way he was able to do it was by using Newton's invention of calculus, which is very difficult math and I couldn't even understand it. When he had his calculations all done and ready to go, he sent them to an observer, which is Johann Galilei, which is the man pictured in the middle, who ended up with exactly where his calculations were, had seen it, and Galilei was the one who named it Neptune, which somebody from the school, from Polytechnic school, was not very happy with, Francesc Argo, because it was not how it should have been. Leverrier should have been the one to be able to name it. But at that same time, Leverrier was not the only one to find Neptune. John Couch Adams was a British astronomer who had found it but didn't have the means to get it out there and present it to the public. After his discovery, Leverrier was given a statue in the Paris Observatory in June 25th, 1889, which is the statue pictured over there. I'm excited.
Any questions for these guys? So George, we were gonna name,
It was going to be named George.
oh, for crying out loud.
Neptune was the name.
No, Uranus was.
Uranus was going to be named George.
Oh, Uranus, yeah. But we like to say Uranus because it adds a lot more humor to the material.
Scientifically, now it's Uranus.
I know, but 3/4 of my astronomy jokes are based on that planet. And if it was named George, it would be, then all I'd have is moon jokes. All right. All right, so the next ones then, oh, that's me again. All right. Nobody's picked these next two, but I wanted to do them just to bring some key points, maybe not necessarily astronomy-based, to light. Anti-jump cannon, and now you're gonna have a whole bunch of people that are gonna be on the 29th. We have 1, 2, 3, 4, 5, 6, 7 people that are gonna be on the 29th, so you can see what's happening now, in terms of our astronomical discovery. Sure. So late 1800s, early 1900s, anti-jump cannon was working for a guy named Edward Pickering at, I think it was Harvard. And this guy had hired a bunch of females to come in, and they called them computers. They were human computers. And he had them looking at slides and doing his work for him. And then, of course, when their work was done, he got all the credit for it. So it just recently, this is coming to light as to who should really truly have been given credit. So anti-jump cannon came up with a stellar classification system based on the color of the star, which she equated to the temperature of the star, and then that led us eventually to understanding the size of the stars. So if you want to know the mnemonic device for this, the star ranking is O is the biggest stars, they're also the hottest stars, they're also the stars that have the shortest lives. M is the coolest of stars, they're the reddest of stars, they're also the smallest of stars, but they lead the longest lives. And so unlike your bonfire, where the more wood you have in the bonfire, the longer it lasts, the more fuel you have in a star, the actual shorter it lasts. And we'll talk more about that when we do the star unit, but that's kind of a counterintuitive idea. The other thing I don't like about this is, when I was in coloring school in kindergarten and I wanted to color a flame, I used red. Okay? Red is not a hot color. When I colored an iceberg in kindergarten, I colored the iceberg blue because, so we're teaching kids wrong. No, probably not. But in science, when something is blue or white, that's a hotter color. It's higher energy than something that's red. And so our classification system, the mnemonic device is, oh, be a fine girl or guy, kiss me. And I'm not sure exactly why they picked this order of letters. But this allowed us now to take a look at stars and get an idea. Here's an old star, here's a big star, here's a young star. This star is going to be around, for trillions of years. This one's only going to be around for maybe hundreds of millions of years. Where before she did this, we really didn't have a good classification systems for stars. So Annie Jump-Cannon, in a time when females didn't do science, they weren't allowed to do science, they didn't have brains to do science, says the white male. But here we are, and so I really wanted to make sure we give credit where credit is due. Beep. Henrietta Swan-Levet is another of Pickering's gals, as they were called. She was another computer. And this one is really complicated to explain. She used what are known as Cepheid variables. These are stars that pulsate at very regular intervals. And so what she was able to do, and this is absolutely genius, she was able to take the brightness of these stars, so how bright does it look, how variable is it, and she was able to use that to measure distances in space. And a lot of people didn't accept this because those distances were far too vast. There's no way the universe is this big. I mean, she's doing these things and she's coming up with, thousands of light years, which we now know thousands of light years is nothing, that's our backyard. But back then, the establishment was like, there's no way. There is no way the universe is this big. Something is wrong with your idea. 25 years later, Edwin Hubble would use this idea with what we're going to learn about from him. And so, absolutely genius. Two of Edward Pickering's gals, he had, I think there were 7 or 8, or maybe a dozen females that were working for him. But I wanted to pick 2 of them, and I think it's absolutely remarkable. And so that's one of my big pushes with students is, it doesn't matter. We have some females that are really brilliant, but they're not encouraged to go into science, and I just think it's horrible. It's absolutely a shame, because female brain works different, they think different, they view things differently, it's scientifically proven, and why wouldn't you want to have a different view on things? It blows my mind that we would discourage this instead of encourage it. But of course the male ego gets in the way, and testosterone and all that stuff. So anyway, so that was Henrietta Swan-Levet, and I think that's it for me again for a little bit, because we have Einstein, Hubble, and Lemaitre now. And they're also going on the 29th. Are you airplaying in, or?
I have my public airplane.
Okay. You're in your little astronomy skirt.
It's dress.
Give me a solid 20 years. Maybe we can figure out how to play it, because I don't know how to do it on my iPad. There should be like a double click thing on my iPad, you can do that.
Double click?
Like a bar on there, but I don't have that.
You swipe down and swipe down again.
Yeah, no, it's not. Oh,
Here we go.
you're a genius.
Oops. I see. Apple TV.
No, you want to find my computer, I think.
A ward.
Hey, Ward.
Ow.
Samantha Zebzelka, that's Kylie Santerre, and today we'll be presenting to you the influences of Albert Einstein, Edwin Hubble, and Georges Lemaitre. And a little bit about myself first. Again, my name is Samantha Zebzelka. I live not too far outside of Sobieski in just a little nowhere house. And I don't know if you know about me or not, but I like to draw, I like space a lot, which is why I'm here tonight. I have 2 dogs and 1 cat and 1 bearded dragon too. So I hope to expand my pets to be like a whole zoo, because I love animals. But that's about me.
I'm Kylie Santerre. I joined this class because I just found it really interesting to see all the patterns in the sky and how they changed during the seasons and how bright they could get and how dim they could get.
So first is going to be Albert Einstein, who was born on Pi Day 1879 and later on died April 18th, 1955. And the significance of this picture, actually, you might learn a little more about it in a little bit. But Albert Einstein actually predicted black holes so long ago, and now we actually have our first picture of a black hole. That's a black hole right there. It's a little bit blurry, but it's there.
That's within the last,
Within the last couple months.
yeah.
Yeah.
Like last April, I think.
I was gonna say about within the last 8 months or so, yeah.
Yeah. So
Cutting
if
edge.
Albert Einstein could have seen that, he would have been ecstatic. So. Okay, so a little bit about Albert Einstein. The man lived kind of a funky life, to say the least. He was born again on Pi Day in 1895. He was born in Ulm, Germany, and later on moved to Munich, Germany when he was a little kid. And then again he moved to Milan in Italy, but then soon after, like a year or 2 after that, he moved back to Munich to continue his studies of like physics and mathematics in a college in Munich because he liked that town. So, and a little fun fact, he actually did not like school at all. He clashed with like teachers and authorities a lot because he hated how school functioned. He hated like how restricting it was. And so it got to a point like he clashed so much that one of his teachers even mentioned, I don't know to what, but one of his teachers mentions like he's not going to amount to anything in life. He's not. Little did that teacher know. But so yeah, needless to say, he did just excel in physics and mathematics regardless of that. And later on, while he was in college, he met his little sweetheart. They had a little sweetheart story where they had study sessions about physics, and it was a cute little love story. Later on, they had 2 to 3 kids. One of those kids is a bit iffy because we don't know if he actually had the kid or not. The story is like their first kid, basically they went and disappeared. Like people knew where they were, but they disappeared for a couple of weeks or months or something like that. And apparently during that time, Albert Einstein's wife gave birth to a kid and then just one day returned back to their house without a kid. So people think that the kid could have died in childbirth or later, like a couple days later, or that they just abandoned the kid in general. So no one knows about that first kid for sure. But the other 2 kids are for sure, yeah. And, oh yeah, and then after that, they got divorced because his wife found out, oh, Albert Einstein is sending love letters to his cousin. And so that was a bit of a funky time. And it was soon after their divorce that Albert Einstein then got married to his cousin, and soon after that they moved to America where Albert Einstein can continue his studies in physics and all that. So as long as you ignore the fact that he married his cousin, it's all good. So you probably know a good majority of the things that he's done, such as E equals MC squared, mathematics stuff, theory of relativity, we're going to learn about that in a little bit. And he helped with the development of nuclear bombs and all of that, and the atom and stuff, so he did a lot of stuff for this world. He was a good guy. So he did, again, like I said, he did a lot. He traveled frequently for work, so he lived in America, but he was like all over the place all the time. And it was just to study things and to like meet with other astronomers, scientists, stuff like that, discuss and all that. And what else did he do? He predicted in Mercury's orbit that it goes fast around the sun and it's really close to the sun. He predicted that. And it was later confirmed that, yeah, Mercury goes pretty fast. He predicted gravitational lensing, which basically means if you have a really big object, it has a lot of gravity. And if it has a lot of gravity, light around it actually reflects around it, bends around that object. So like a good example of this would be like if you looked at our sun with a really good telescope that wouldn't get blinded by the sun, you would see stars around it actually bend a little bit. Like you might see a star that's like here and then also here at the same time. I think that's how it is.
It would be like, let's just pretend that my thumb is the sun and you're the star. I can't see your face right now, but with gravitational lensing, I would be
Yeah.
able to see a distorted view of your face.
Yeah.
Because of that ability to bend light.
So he predicted that. It was later on confirmed by some other scientists.
From a solar eclipse?
Yes. Yeah.
Oh.
And then he also predicted the existence of black holes, which again, the significance. We got a picture of a black hole now. And he predicted the existence of black holes with his theory. Go right ahead. His theory of general relativity. It fits in there, I swear. But basically, he discovered this theory of general relativity. I can't speak. And the theory basically explains that things are moving all the time. And the universe is expanding. So galaxies are moving away from each other. They're just all moving away from each other is basically, in essence, what it is. And he predicted it, but he didn't like it. He thought that the physics of this was just absolutely, it doesn't work out, because he grew up in a lifetime where our galaxy was the entire universe. There's no way this can be happening. No, he didn't accept it. He considered it his biggest blunder. So, and there's also a couple of gravity things within there. Theory of general relativity is like gravity will attract things. I'm blanking on it right now, but it fits in with black holes because he predicted black holes using his theory of general relativity. But I'm not going to try and explain. I just make things more confusing. Go on.
So I have Edwin Hubble, and he has an aptly named telescope after him. So he was born on November 20th, 1889, and he died September 28th, 1953. He was one of 8 children. He served in the military in 1917, which was World War I, and he was the first one to sort of confirm the expanding universe because of Albert Einstein's theory of relativity about things expanding and all that, and so he actually observed it firsthand. And so this telescope will be important in the next slide. Just know that that's the Hooker telescope, which was the best telescope that they had at the time. And so how he confirmed the expanding universe, in 1919, Edwin went to the Mount Wilson Observatory, where the Hooker telescope was located. And as Samantha said earlier, everyone thought that the Milky Way was all there was to the universe. But Edwin found a Cepheid, which is a type of star that he calculated was millions of light years away, which was farther away than how big the Milky Way was. And he used this by the redshift in the spectra, which means that the more redshift there is, the farther away it is. And I have this neat little video that explains it a little bit better. If I can click on it.
Fun science, fun science, fun science, it's a science of fun, yeah. Today I'd like to tell you some cool things about light! Now, as I'm sure you're aware, the speed of light is 299,792,458 meters per second, which is pretty bloomin' fast. To give you an idea as to how fast that actually is, it would take a beam of light 1.255 seconds to travel from the Earth to the Moon. The speed of sound is only 340 meters per second, which is still pretty fast, even though, thanks to science, humans have managed to go faster than that. But if you want to go faster than light, then sorry, you can't. It's not possible. It's theoretically possible that we could one day travel very, very nearly almost as fast as light, but to go faster than that's No, sorry. Now before I can tell you about all of the really cool stuff that comes with light and the speed of light, I have to tell you about this other thing called the Doppler effect, which is still really interesting, so don't leave just yet. The Doppler effect is the change that you notice in the frequency of a wave when the source of that wave is moving relative to you. For example, imagine that you're sitting by a canal enjoying the lovely British weather when suddenly I appear next to you screaming like a lunatic. From your perspective, it's just really, really weird. However, if theoretically I wasn't standing next to you but was running past you at 80 miles an hour, still screaming just as I was before, as I approach you, the pitch of my scream would be higher, and then as I pass and run away from you, the pitch of my scream would drop, even though from my perspective, I'm screaming at exactly the same pitch as I was when I was standing still. The reason this shift in pitch happens is because when I'm sitting still and screaming, the sound waves are emitting from my mouth uniformly. But when I start moving, the sound waves in front of me get squished up and the sound waves behind me get stretched out. And it's this change in the frequency that causes the change in pitch as I pass, and that is what the Doppler effect is. The reason the Doppler effect is important is because it doesn't just apply to sound, but it also applies to light. Bet you didn't see that one coming, because it's not a video about light or anything like that, is it? Oh. So just as when something is moving and emitting sound, you can hear a difference in the pitch of that sound, when something is moving and emitting or reflecting light, you can see a difference in the colour of that light. For example, imagine that we're in exactly the same running canal situation as before, except this time I'm not screaming like a lunatic, and instead of running at 80 miles an hour, I'm running at very, very nearly almost the speed of light. What would you see? Well, you probably wouldn't see anything at all, because as you'll remember, the speed of light is very, very, very fast, and I'd be gone before you even knew I was there. But let's pretend that you had a magic iPhone app that would let you take pictures of me travelling very nearly at the speed of light. What would you see? Well, when I'm running towards you, the light in front of me gets squished, and the frequency of that light gets shifted to the blue end of the visible light spectrum, and so I appear blue. And then as you see me running away from you, the same thing happens in reverse. The light behind me gets stretched out, shifts to the red end of the spectrum, and then I appear to be slightly red. Now this change in the frequency of light is something that happens all the time. In fact, it's happening right now as I move forwards and backwards from you, but the change is so negligible that you can't notice it unless something is travelling at very, very nearly the speed of light. But easily the coolest thing that happens when you travel at very, very nearly almost the speed of light is that when you do, time slows down. All clocks, whether man-made or biological, like me, tick slower when you're travelling that fast. So back to our thought experiment where I have the ability to run very nearly at the speed of light. Imagine that I've decided to take a couple of minute tour around London travelling that fast. Well, it might have only seemed like a couple of minutes to me, but to you, travelling at normal human speed, it would have been many, many years. And so by the time I returned from my very short run, you would have died of old age. And that, ladies and gentlemen, is light. This is the end. Bye.
So that basically explains how he calculated that the farther away the galaxy is, the more redshift it has.
So you're telling me, let me just see if I have this straight. He was looking at these objects that he thought were in the Milky Way, but he noticed this red-shifted light, which equated to objects that were much more distant than the Milky Way.
That's correct.
And Einstein's theory predicted this should be the case, and Hubble observed it and confirmed it.
Yes.
And so Einstein now must be
He's furious.
furious or ecstatic, one of the two, that his idea was right, but his heart led him down the wrong path. Is that what
Yeah.
you're telling me?
And then our last scientist will also.
It's like that thing you mentioned before, where sometimes scientists just can't let go of their morals enough to look at the actual facts of what they're figuring out. That was Einstein.
Yeah, he would spend years trying to figure out where he screwed up. And it turned out he didn't screw up at all. But what a great problem. If that was his biggest blunder, as you said, to have that be your biggest blunder where you said you were wrong but you were actually right.
I wish my blunder equated to the expansion of the universe.
Well, yeah.
So next we're going to be talking about Georges Lemaitre, who was born July 17th, 1894, and died later on June 20th, 1966. So before we get into the meat and bones, we're going to be talking about a little bit about him. He was born. Ignore this.
July
You don't see this.
17th.
July 17th, 1894, in Belgium, Germany. And he didn't have much in his early life, so later on he served in World War I for a bit. After World War I, he, that's not what I have typed down, oddly. But after World War I, he worked and then later got ordained to become a priest in 1923. So he was a priest, actually, believe it or not. And he's doing astronomy things. So they both can relate. You can do astronomy and be religious. But later on he became a lecturer for physics and other science stuff at colleges and all that. And one of his discoveries, as he was obviously around the time of Edward Hubble and Albert Einstein. And so he saw Einstein's theory that the universe was expanding, and he thought, like, well, if it's expanding, shouldn't it all have come from one point? Because things don't just expand, they all seem like they're going in a certain direction, that all, like, if you put the video in reverse, the universe in reverse, it would all come from one point. He thought that was, it made sense. It obviously does. Things don't just expand without having an origin. So he made this prediction before Hubble confirmed it, actually. And he proposed his prediction that everything comes from one finite point, everything in the universe, everything comes from one finite point in a British Association conference, basically. That's where he proposed it, and it's basically like this big science fair, that's what it was. So, and he originally proposed it as a homogeneous universe of constant mass and growing radius, accounting for the radial velocity of extragalactic nebulae, otherwise known as the primeval atom theory. Otherwise, how we may know it today as the Big Bang theory. So, he proposed it there, and basically what the theory all is that everything in the universe, everything from you to you to you, that exit sign that I pointed at by accident, everything in the universe came from one finite point that was about the size of an atom, hence the primeval atom theory, which now is Big Bang theory. And from that point, it just became so dense and so hot that it all exploded into the universe. It was hot for a while to where nothing could form, and then it eventually cooled down as expansion happened, stuff started forming, electrons started forming, and atoms and all that. You'll get to learn about that later on, but essentially everything formed from one little finite point. And basically what he did was he took everything that was predicted before from Hubble and Einstein and just combined it into one theory. He's like, this is how the universe began, the Big Bang theory. And that's why we're excited.
Thank you.
So, the Big Bang is a horrible misnomer.